Java or JavaScript or C++ or C# or whatever. They will do the same thing. You have memory, right? And you have a CPU. The memory, the only thing it does, it's keep values. The CPU, its purpose is to modify them. Okay, so the memory, the only thing it does is either writes, the CPU writes the memory or reads from the memory, modifies it, and then writes it back. And it always does this. So read, read, execute, write. Okay, read, execute, write. Good so far? Someone say something. Like, I want to hear some response. Good so far. Yes, no? Okay. So let's say that in memory, you're storing the value 56 and 39, right? Now, in memory location, it's another number. So this will be, I don't know, location 100. This will be location 101, 102, 103, right? So in your code, you would say something like, go to location 100, add 50 to that location. No, go to location 100, get the value of that location, add 50 to it, write it back to location 100, right? So notice what we did here. We read, will be a go to location 100. We did the process, right? We read from there, we did the process, and then we wrote back. Okay, these arrows don't make much sense, but you get the idea. We read from memory, right? From this location 100, we did the process, and then we wrote it back. And that's all you're doing in programming, right? When you see in programming, let me see if I can open the project so you can see it. The hell is Visual Studio at, man?
What the hell is that?
All right, in C#, you see how you're saying, okay, let me leave the class here. You see how you're creating a class and you're adding variables and you have this thing and there's methods down here and whatever and whatnot, right? So you're like, well, Carlos, this doesn't look like you're reading from memory or writing to memory or whatever. So what the heck is the class person doing, right? So all you gotta do is remember that the class, all it does is hold data. So let's go back to our example. So like I said, class is a container. It's sort of like a box of data. And that data is predefined, the data type. So it can be a float. It can be a float data type, or it can be a byte, or it can be a integer data type, right? And the type of data is just basically how do you read that data? That's all it does. You know, if you read it as a byte, then it's going to read as a byte. If you read it as an integer, then it's going to read as an integer. If you read it as a float, it will be the float. This will be the integer, and the byte. I don't know how the byte form looks like, but you get the idea, right? You get the idea, right, everybody? Okay, I'm glad. Okay. So a class, like I said, is a container of data, right? So when we write something to memory, for example, a single int, all we do is just say, okay, computer, I need you to write 56, for example, to memory. And then computer to be like, okay, I'm gonna write it to location 50, location 162, for example, 162. And here's 56. And you're like, okay, all good and handy, right? What a class does, since a class has multiple members, like it has 56, 78, or it might have a hello, or it might have a 53.1, whatever. It's gonna say, okay, I need you to go look at my class, and for all its variables, you're gonna write it into memory as well. So it will be 56, 78, hello, 53.1, whatever, right? And this will be the beginning of your class. And this is basically what instantiating a class does, right? If you look at your Visual Studio Code, what we just did there is this. Writing the class to memory is this, right? This is what we did. This, put it into memory, is the same as doing this. Good so far? Amazing. Now, writing a class with variables inside of it, they're called members, by the way. All those variables like int, float, whatever, they're called members. And writing that into a class, it's just like doing this, right? And so again, every time you say new and then your class name, it's gonna put this into memory and then this into memory. All good? So in this case, the class person is a container for a string, for a float. Don't worry about the reference now. It's for a string, for a float. Don't worry about this, and for a method. I guess it will make more sense if I don't write it inside of a Visual Studio. If I go into the other one, because Visual Studio is gonna apply. It's gonna tell me that the code I'm writing is wrong. Whatever. All right. So then again, this is not the syntax, by the way. So I just want to show you, give you an example, whatever. So then again, when you write a class, there's gonna be class A. I don't know. Let's call it car, right? Class A car will have the member. We'll have an integer inside of it. We'll have a float, a string, and each one of these things is a different member, right? Everybody get it so far? I'm gonna turn off the highlighting because it's gonna confuse you more. So every time you create a class, remember it's a container of data. What does it contain? An integer, a float, a string. Okay. I don't know what else to explain. I don't know what else to. I literally do not know what else to explain. So these are those. So that is what a class is, right?
I have something I don't understand. Arrays.
Yeah. What's up?
Arrays.
What happened?
Can you explain arrays? I don't know what's
Arrays. Arrays are a container of data that are all the same. So if, let's say you create an array of integers. I mean, this is not the syntax. Again, this is not how you actually write it. But an array of integers contains an integer, an integer. It depends how big you want it, right? An integer, an integer, an integer, and only integers. But if you make an array of strings, then it will contain only strings. So it's just like a class, but all the members are the same.
So how is it written?
Are you doing a class?
Yeah.
Bruh, why now?
I don't know.
Okay. Okay, see you later. Bye.
Peace out. Okay. What was your question again?
How do you write an array?
Okay, to write it, this is the sort of like the grammar to write an array, right? You go to the class or struct. If you want me to explain structs, that's just fine. So you go to the yeah, it's alike, but it has some main differences. All right. So you go to your class, and to make an array, let's say of integers, right? We just say int array, and then the reference, which is rar, whatever. Oh, and by the way, every time you name something, like rar is referencing an integer array, that basically means that reference is in the point of memory. Just like I explained before, this will be location 101, this will be location 102, this will be location 103. And keeping track of these numbers can be cumbersome, right? Can be difficult, can be tiring. That's why you name it something. Everybody understand?
Yes.
That's why you can name this. That's why you can name this. That's why you can name location 101 as height, whatever, or width, or weight. And weight is just referring to location 103 in memory. Okay, all good? Okay, I hope it's all good. I didn't hear anybody say anything, but
Yes, that's good. But so how do you use the array? Like, if you wanna just to put it in a method, how do you
okay.
call
So let me go again. Let me just show you how arrays are stored in memory. Where's my pen tool?
Did you're lucky?
So imagine this is my memory block again, right? Just know that arrays have a fixed size. So if you create an array, let's say int array of 5, it's always going to be 5, right? And how array gets stored in memory is the computer says, oh, you want to create an array, let's say of size 5, whatever. Then it's going to say, okay, your location in memory is going to be this location. This is where we're going to start. Your first value is going to be there, 0, for example. And then after that, 5 after, it's going to be the rest of your array. So it'll be 1 there, 2, 3, 4, 5. Right? And this is how it gets stored in memory. Now, you can tell your program, okay, let's say you want to access location number, this location right here, right? Which is the 1, 2, 3, 4th. This is the 4th location, right? The way you do it is that you go to the beginning. This is how the computer does it. I'm just explaining to you so it makes more sense when I show you in code. You go to the beginning of array, and you have a 5 offset, basically. So you offset 5. 1, 2, 3. No, wait. If you want to access the 4th location, you're gonna offset 3 times. So 1, 2, and 3. So this will be location number 3. Even though it's the 4th location, it is the 3rd offset. Okay. So that's why when you access the array, it's gonna be in size number 3. So let me show you in code how that looks like. So we created an int array, and notice how I have not initialized this array. So it's not being saved in memory, whatever, right? Say it again. Because I'm sort of like declaring it, but not initializing it. The only way something gets saved into memory, the only way you can save something into memory is if you tell it to, right? So the way you do it is just saying new something. So let me create a method real quick. So let's say this. Now this is setting, okay, it's giving me an error. But it works. Okay, this right here, this little piece of code is creating an array of integers of size 5 into memory. So then again, it's doing this 1, 2, 3, 4, and 5. Now I need a reference to the beginning of the array, right? Okay, so I just give it a name. Remember, int rar, it's the same type, an integer array. I just have to set it equals to that. So rar will reference new int of size 5. And let's say I want to access the fourth position. Well, that would be offset number 3. Remember, third offset, 1, 2. No, wait. This would be 1 offset, 2 offsets, 3 offsets. Yeah, because 0 offset will be the beginning. 0 offset nothing. This is the first one. Offset 1, offset 2, off. You know what offset means, right? Like I'm not just spitting out random words. Like offset, right? Like it makes sense to you? Okay. So that's what you're doing. So if you want to access the fourth member of an array, all you have to do is rar. So the reference, again, rar, a third. And this would be the fourth member. Okay? And then it's giving me an error because I'm not setting it anything. So let's say it is equals to 56. Exactly. 56 will be equals to the third offset of the array. And notice the name is just like a reference to it. It's just a location in memory, right? It's the way for you to know where that value is. Because if you don't set a name, it's just gonna write it to memory, and then you never get it back because you don't know where it is. Do you guys understand that? I hope you do. So that's why you give it a name, and you give it the same type. If it's not the same type, it's not gonna work because it won't know how to interpret the ones and zeros. Because everything in memory is ones and zeros, right? And the type is what defines how to read that ones and zeros. I hope that makes sense. Okay. So like I said before, classes are containers of data. So let's just create some data in this container, whatever. We have an integer. We have a string. Let's call it name. And then we have a float for height. And then we have an integer for perfect. I don't know. For I don't know what you want an array for. A list of what?
How many fingers you have?
Perfect, right? So let me show you what methods are. Oh, by the way, all the data that is inside a class, they're called members. So name is a member of type string, height is a member of type float, fingers is a member of type int. Cool. And remember, fingers, the name after is just the reference in memory. So it's how to get to 101 location in memory, or 102 or 103 or whatever.
Is it possible to make a bool an array?
Yeah. Anything can be an array. All reference members or all data types can be an array. So you can make a person array. You can make a bool array.
You can make an array of arrays. Just
know what?
keep
You're
going
right.
deeper with arrays.
You're right. So let's create an int array of arrays. And let's name it. All right.
For every index in that array, that contains another array.
That's what that means. I hope it doesn't make too much sense. Is this even possible? It
Yeah,
is.
just keep going. At that point, you've probably got a problem, but you can do it.
Wait, I missed something here.
Yeah, syntax. Yeah, you didn't. Yeah, here we go. Now it's fine. This is fine. There's
This is
nothing
a-
wrong here.
This is an array that contains an array inside. That contains an array inside. That contains. Right, you get the idea.
You're gonna need a lot of numbers to actually access anything in there.
Yeah.
I didn't expect to be walking into a classroom. Hello.
Hi. All right. So remember, classes, containers of data. Perfect. Another data that you can contain is methods. Right. So you can make a method. Methods are just like another reference. So you will have the return type, or the type, and then you have the reference to that method, right? So you have, let's say, an integer called kill. Don't worry why it's called kill. And then all methods will have an open parenthesis and a closed parenthesis, and then they will have a body. And this is how you define a body. They have a body because they execute code. And every time you execute like executable code, you write it into a body. So again, this method, all methods, remember, they have a reference name, open close parentheses, and a return type. Maybe you've seen this before. All right.
How can how can like something like an integer or a float become a method?
It doesn't become a method. The method just gives you an integer when it's done calculating its calculations, right? Does that make any sense?
Uh, this is the
So
one thing that I get confused over. a lot.
okay.
With void, it's made a bit easier for you, but every method has a return of the type that it's expected. Void is returning, well, more or less null, so it just doesn't ask for anything. But everything is saying, okay, I come into this method expecting to get an int out of it, for example, in that one.
Okay, let me give you an example of how a method that returns an integer will work. So let's say that you have a method int. Whoops, my handwriting is horrible, by the way. An int called kill, right? And so let's say you also have a variable of type int called kills, whatever. So let's say you want to say, let's call this to separate it, killed amount.
I shouldn't be here. I'm just distracting myself from actually committing to something in my project.
Yes,
Fucking
same.
scary. Goodbye.
Kill amount, right? And we can set kill amount to kill. Now, what does this actually do, right? So kill is going to execute its code. It's going to do kill, I don't know, it's going to say, okay, execute code here, code there. I'm just doing this, but you can imagine your own code, whatever. An extra code, modify data, and then it's going to say at the end, return, and the return type is already defined on the top, remember? Int, it returns an int, right? So return an int. So it will be, let's return 53. And so this will say, okay, int will be set equals to kill. Okay, now we're going to execute kill. Kill is going to do some code, more code, modify whatever, and then return 53. So at the end, kill, the variable kill amount will be 53. So let me give you an example of how that would look in code, right? Let's say we have
Wait. Return 53 what? Just a number or
yeah.
Oh.
Right. So let's say we have kill, right? Let's say that kill, I don't know, this might be a little bit too advanced. Okay, it's not. Kill, all that kill is gonna do is gonna get the length of fingers. No, because fingers could be. Okay, perfect. So inside the integer, I'm gonna say int a equals to 49. Int b equals to all right. And then let's do like a bunch of mathematics here, where int c equals to 0, right? Anyone, you guys notice what I did here? I created 3 variables and I wrote it into memory. And this will be the reference. This will be the memory, the value of the memory, and this will be the reference. Value of memory, reference. Value of memory, reference. Now I can go down here and I can say C equals to A plus B. A plus B minus A times B, right? Whatever. And then I can say, oh, return C. And C is the reference to the value type that is being calculated right here. So let's make another method real quick. Oh, whoops. And now if I say, let's make a new integer. Let's call it int the kill count, right? This would be the reference, and that reference is referencing. So I'm gonna say kill count equals to kill. And every time you write a method, you always want to put you're always going to put the parentheses. So what this is basically saying is, okay, the value stored in this location is gonna come from the method kill. So it's gonna come to line 41. It's gonna say, okay, execute kill. Kill is write an integer to memory, write an integer to memory, write an integer to memory. This integer in this memory location is gonna be this plus this minus a times b, whatever. Okay, and then return that memory location, that reference, right? So it's gonna come down here. Okay, now we know that kill returns this memory location. So kill count will be set to the value of that memory location. Okay, if we want a way to visualize this, I'm just gonna, don't pay attention to this code because this might be a little bit too, well, it's not. So every time you initialize a class, it's always gonna call a method called the constructor, right? So remember, every time you initialize a class, it's always gonna call a constructor. So it's just a method like any other, like kill or other method. It's just their methods, right? So the way you make a constructor is that all constructors, they're gonna be public and they're gonna have the same name as their class. So it's gonna be public person, open close parentheses, and make a body for it. Yeah, you must always make it public. I think if you leave it like this, it's actually not gonna work. It does work. What? Oh no, it doesn't work. I don't think it works. Whatever. Okay, so in the person class, so remember, the constructor is called when the class is initialized. Initialize means when you're gonna write it into memory, you're gonna call this method. So in this method, I want to output the answer of kill. So the integer, which is return C, right? Which is, we did all these calculations, we did this, and then we return the calculation, right? So I want to write that answer. So I'm gonna say, this is just using a namespace that contains a class that's gonna help us with the output. Instead of in Unity, use debug, which is the class, .log, which is the method, to output something to the console. In this case, we want to go into the namespace called system. And namespaces are just more containers of data. Namespaces contain classes and other sort of data inside of it, but it's just a way to organize it, right? So we go into the namespace system, and then the dot means we're gonna go into another thing called console, which is the class. So namespace, class, and then you access the class's members. Again, the members are the fields, the references, and these methods. So system, namespace, class, console, that one of its members, which is called log, which is a method. Well, it's not called log, it's a write line, my bad. And we went to write line, and we see that if we put a comma here, you see the many different things that you can put into write line. It accepts nothing, or a boolean, or a character array. And I'm saying or because C# has something called method overloading, which I'm going to teach you in a moment. It's not as difficult as it sounds. So write line, and if we keep scrolling through this, you can see that one of the things that we can write is a integer. I don't know if you can read it from here, but it says int value. And what do we have? An integer right here, int, right? So we can say kill. And okay, so how do you initialize a class? You're gonna go into your program, and then the main method, it's called every time your program starts. Every time you make a new C# program, it's always gonna call the main method first. This is the start of your code. Now, if you're doing it with Unity, you know it's already done in the background for you, so you don't really have to worry about it. So we say main, and we're gonna initialize a new class. Super simple. The way you do it is with a new keyword. This is how you write it into memory. New, and our class type, which is person. Notice how I put the two things here, right? Remember how I said that this, every time you write this, is because you're writing a method. And since person class, all classes have a constructor. Since they have a constructor, you have to put the two parentheses. Even though you don't define a constructor, in the background, when it gets written into machine readable code, it's just gonna do it by itself. So it's gonna do public class. Wait, class is person. Public person. This is what it's gonna do for you automatically if you don't define a constructor. So notice, initialize it, and when we initialize, we call this, which is system.console.write line that kill, and this is the only thing that it has inside. So now if we run it, I don't know if you can read it, but it gives you the number, which is a negative number. Which it doesn't make any, well, it does make sense. All right, good so far? Yeah. Remember, person A, that will be defining the data type, and A will be the reference of memory. Remember, it's like assigning the value of memory to a number. So this will be 101. Remember 102. And if you don't want to say 101, but you have to give it a name, right? You have to give it like an actual worded name. So instead of being 101, you can give it like A, and this will be where the person class gets stored. So when you say person new, it's gonna get stored in this chunk of memory, and you reference it by saying A. So A will be A, this chunk of memory, and you can say dot B, which is okay. Go to this chunk of memory, and then go to the other reference of that chunk of memory. So go to this, and then go to this. Basically, that's what it means. So this is how you initialize it. But then you initialize it, but then you want a reference to it so you can modify it, right? Right. I'm right. The only way to initialize a class is with a constructor. And again, we can set a reference to it by saying, create a new reference of type. So create a new reference. Let's give it a name. Name of Manuel, right? This is the reference. Okay, that reference is going to reference the thing that we just instantiated. But that reference doesn't have any type, and we need to specify that. So the computer knows how to read that data that's being stored in the thing that we just instantiated. This is this is something called static typing, where I think that's what it's called, where the language wants you to specify everything. If it's not specific, then it doesn't work. It's not like Python where you can set a number to a string or a string to a boolean, whatever. You know, I don't know how that works exactly, but you get the idea. So you have to specify what manual is. Manual is of type person. So this will be the reference. This will be the memory. Exactly. Yeah. You will call, that's to call the members. A method, it's a member of the class. Okay, good. So let me teach you about access modifiers, right? You see this public keyboard? That's an access modifier. Another one will be private. Another access modifier can be protected. And I think the other one, the last one is private, protected, and public. So these are the 4 different access modifiers that exist. The 2 main ones you're going to be using is public and private. Public means that you can access the members outside of the class, which means that when you're instantiating it, you can say manual. Let me see what the public member was. Manual.people, right? And if you try to modify this data, it's going to let you. But if you're trying to modify manual, if you're trying to modify the name from outside the class, manual dot name, you see how it doesn't autofill. It's because it's private and it won't let you modify it outside of the class. So this reference is locked to be only used between these 2 parentheses over here. Nothing else can access it. If it's not between these 2 parentheses, then nobody else can access it or modify it or whatever. I don't know what else to teach. Give me an idea. What questions do you guys have? Okay, amazing.
I don't know. Wait. It's something I didn't understand when you said. It's like you said public person array people. Yeah, this one.
Okay, so you're
I-
creating a reference. Okay, you're creating a reference to a point in memory, and that reference is called people. Now,
Okay.
what type? What?
You wrote it inside of the class.
I know this might seem a little confusing, but yes, you can have a class inside a class that is the same class.
Wow.
Mhm.
And then if this class is not referencing anything, then it would just be set to null. If this reference is not referencing anything, then it will just be set to null. If it's not a referencing memory, then it will be set to null. Okay?
Okay.
So like you create the reference, right? So like int, not an int. You create the reference person,
What's this problem? What's this program?
C#.
No, this is driving.
Affinity Photo. It's $50 or $60 on the Windows store. That's
thanks.
where I got it. Yeah, it's a pretty good program. It's like Photoshop,
Yeah.
but
It seems so good.
not as expensive. All right, so you guys get the idea of classes and things. All right,
Yeah.
so remember, create a reference. When you create a reference just like this, you see how I'm not saying equals to something, right? No, it doesn't work. It's so basically this reference is null right now. When this class gets put into memory, people, the reference people is set as null, right? If I want people to actually have a value in memory, then I'll have to say equals to new, which is how you create something in memory, equals to new, and then you have to create the same type, which is a person array. You know, a person array, and then you can give it a size, whatever size you want, 100,000, 100,000. You know. Notice that you cannot initialize an array without anything inside it. If you initialize an array, it has to be greater than 1. So 1 or greater. Or it's going to be null, which is this. Let me teach you about structs. Okay. And structs are very simple, right? Public struct, the cool data. It's not cool. A struct is a class with a twist, right? A struct can have members like int a. It can have the members can have access modifiers like public int b, and they can also be but if you create the members, you cannot initialize them, right? This is not initializing the members. This is defining them. So you're defining that cool data has an A and cool data has a B. Or in other words, cool data has an int and cool data has another int. So good so far. But if you want to initialize something, you want to say public person, for example, and then you want to initialize a person, you cannot do it. I have to say new. It won't let you do it. Okay, I don't know why they just made it this way. If you don't like it that you cannot do this, then make it a class. But sometimes you just want to have like simple data, like an int a. Let me give you an example that Unity actually comes with. Unity has a vector3 of type struct, right? And all it has is an int x, a public int x, and then it has 3 more, y and z. And that's all vector3 has. And it also has a public void, I think it's static void 0, for example. And then it has it returns actually a vector3. And then it has a public static vector3. And then it's called up, for example. Right? And then it will return a vector3 that's pointing up. See how in here it gives you an error because it's expecting for you to return a vector3 and you're not telling it to return a vector3. For that error to go away, just say return. No, because this makes no sense to the computer. Vector3 is nothing. You have to say return a reference in memory, right? Vector3, it just, what do you want me to do here? I cannot return the type. So you have to say new and then instantiate it. Or if you already have a vector3 reference, like let's call it res equals to new vector3, you can just return res. So if you already have it defined, you can return that instead. Same thing here. In this case, I know that it is I know that vector3.up is res.y equals to 1. So in this case, this vector will be 0, 1, 0. And this vector points up. So I can just say return res. And this is probably what Unity has. And so now, let me teach you about static access modifier. What the static access modifier does is that instead of belonging to a reference, remember how do we make a reference? We say type of the reference, name of the reference, it's just a different way to manage data. For example, if you create a yeah, I know you have that confusion, right? Like just fucking struct is just another type of class, whatever, but it's a different way of managing data. You know, if you see a struct in a program, you say, oh, that's probably like a simple little thing, like a simple data type. If you see a class, you probably think, oh, that's like a whole system, you know, that has many things, you know. So in here we create a constructor because these things do have constructors. So if I just type this, Visual Studio will fill it out for me. Super handy. You see that it gives you an error, right? But this one, my class, if I just delete everything, by the way, you comment things out by saying this. When you comment something out, it's not gonna be seen at all, okay? Perfect. It doesn't. What? Oh yeah. Yeah. So the person class does not give me an error even though it doesn't have anything inside. But the vector3 struct does. And it gives you that error because every time you specify a constructor, you must also specify all the like characters, all the variables. You basically must give all the variables initializers. You must like initialize them explicitly. So you have to say that x equals to 1, for example.
Hello there, mate.
And you can say that y equals to 23, and then you can say that z equals to, I don't know, like 69,420, right? And notice that it still gives you an error because you cannot create an initializer without nothing inside, right? And you're like, what do you mean something inside, right? So methods, you can actually input things into methods, right? You can input a int, and then the name of the int. You can input another int, and you can do this with every data type. Data types like int, float, you know, a class that you created, person, things like that. Perfect.
Can you use different types of data?
Yes, you must.
Like you can use in the same method like int and float, right?
Exactly. So int, float. You can even use a custom type like person that I created myself. You have to name it different though. Okay, amazing. Goodbye, Vector3. Did I explain what static meant? Shit. Okay. So remember, classes, they have members in them, right? And the members have an access modifier. The access modifier will tell you how you can use that variable. If it's public, use it anywhere. If it's private, only within the class. And the static access modifier means that you don't need repeat it again. Right. So private int, whoops. Is that a method? So void method int b equals 3. No, every member, I guess you want to call them, every field that you make inside a method, they're always private. There's no way to get them out. So every time you initialize something inside a method, there's no way to get them out. They always stay there. they stay between this curly brackets. So this private int a will stay between the curly brackets unless it's public, then it goes out. Okay, so the static modifier, all it does is that it doesn't belong to an instance of the class, rather to the class itself. Think about what I meant, right? Think about what I told you an instance was. An instance, remember, is when you say new person. And here you're creating an instance, right? How do you reference that instance? You say, you give it a name, guy. You set it equals to the distance, and you need to specify that guy is the type of the instance that you're creating, which is in this case is person. And now notice that if I want to access, let's make this public so I can access it outside of the class. Let's make this private, static. If I want to access A, I have to create an instance and then set a reference to it. And to that reference, I have to say guy.a. And this is the only way I can access the A variable inside of any instances, right? But since the static modifier says that it belongs to the class itself, then I don't have to create an instance. I don't have to say new this and then set it to a reference. I can just say directly person.b. And B, you can see, is static. And it gives me an error because I'm not doing anything with B. I think actually it's like this. Okay. Notice how I don't put parentheses because this is not calling a method. This is referring to the class itself. So person.b, you're going to say, and you see that B is an int, so you can make it an int here. And this works. And I can say the same thing for here. Notice since B is static, it belongs to the class itself, not to the instance of a class. I hope you're good so far. This is gonna like probably fly out of your head, but okay. So I explained structs, classes, and what they do. Okay, this is a little bit more complicated, what I'm gonna teach now. This is polymorphism, right? And how classes can be other classes at the same time, right? So let's say we create what we call a base class. Call it public.
Wait. Before that,
What's up?
can you just explain more about arrays? Not what they mean and what they do. I mean, like how to use them.
Okay, I'll do that. Public. Oh, and by the way, notice that I can also say public static class, right? And I can create the class being static since the beginning. And I can make it human class. Now, the human class, let me create another class called the public person. Public class, my bad, person. And remember, since person is not static, it belongs to a reference, not to the class itself. So then human, let's call this God, fuck it. God will have a reference to other humans that are in Earth, right? So let's create an array for that. We can say create an array. So create an array, create a human, create a type, human, right? Make it an array and name it, and the reference is gonna be rain people. And this gives me an error. I don't know why. Oh yeah. Since God is a static class, all of its members must also be static. So you have to say this. If it doesn't have an access modifier, it's automatically private. If it's not public, it's private. It's not protected, it's private. So, yes, all the members. Int will be a member. The methods are members. All of that will be to declare static in a static class. And since I didn't tell it to be public, it's going to be private automatically. So public static human array people. So notice how here I'm setting the reference, but I'm not setting it to a location in memory. Therefore, people will be equals to null. And we can actually test that if we create a constructor. I don't know if static classes have constructors actually, because they don't get initialized. They don't. Okay. Let's create a public method. Let's create a method, a static public method that will return an integer. And it's going to be called the count. And all this does is return people that length. And the length will give you the length of the array. Exactly. Okay. So now let's go into another array, into another method, and let's make it public static add or change. And I'm calling it change. You'll see why. Public static, void, my bad, change. Actually, no, we don't need this. I don't know why I did that. My bad. So we have a human. Notice that humans right now, the array is set to null because it's not being set into memory. Let's go into our main method, right? This is where our program is going to start. Okay, the first thing I want to say is God dot people, and I can say this because it's static, will be equal to a new, in other words, initialize an array in memory. Let's call it people. You're going to initialize it with a size of 33. Woof, too many. Of 5. Oh, I forgot the... Oh, it's human. It's not people, it's human, my bad. And this goes away. There you go. So God.people, people is just a reference to an array, will be equals to, exactly, to the new initialized array of 5, size of 5, right? So we're going to say that people, this is how you access the array, right? So I'm going to say God.people you're going to say at 0 of an offset will be equals to a new human. Now, let me actually tell you something. When you initialize the array, you're initializing the array, but not the elements of the array. So if you want to access array at number offset 2, that would be null. But the array itself is not null. I'll give you an example right now. Let's make this 1. Let's make this 2. Let's just to differentiate them. Let's give them a name like public string name. And now in here we can just say God dot. So I'm going to go into the God class, access the static member people. And since it's an array, I have to specify the offset of 0 dot name. Name is just a member of the human class, will be equals to Alfred. And let's do the same thing for the other ones. 1, 2, let's call this one Carl. And let's call this one perfect. Shit, I need the ghost. Hold up. I'll get you a ghost. Ghost. Now, what do you think about that? And now, now I'm going to access a class that was created by the C# developers called console. And console has a member, a static member. See how I can call the class directly? A static member called writeLine. And right line, if you look through the different options that it has, you're going to see that one of them is a string. Option 11 is a string, right? So I can just say, okay, write this to the console, which is going to reference this. And I'm going to do the same for the other ones. 2 and 2, right? So this is going to write 3 different names. If we click and play, there you go, Alfred, Virgin Boy, and that character does not know how to render it. I don't know if you can read it from my share screen. I don't know if it's too small, whatever. Whoops. I don't know if I can actually. I don't know if I can set the font of the thing larger. That way you can see it better. Whatever. You get the idea. But now, notice how this array has 5. We only changed 3 of the array, right? What if I want to write? What if I want to write to the console? Exactly. And I want to write the enum of it. What's going to happen? What do you guys think? Make your predictions right now. What's your hypothesis?
Not gonna do anything.
What do you say, Virgin Boy?
It's not gonna do anything. It's not
Okay, let me explain to you again. What this is saying is that you want to access the name of the people, of the human, at the 3rd offset. What do you think is going to happen if you're trying to access the human at the 3rd offset when the human at the 3rd offset is not being set, and which means that it's null? Let's see what happens. And we run, and it says object reference not set to an instance of an object. This is basically saying that the 3rd offset, which is the place in memory, is not being set to something in memory. So how do you want me to get the name of that if it doesn't exist? That's what this is basically saying. Right? So we have to specify up here. If we go up here and we say the 3rd place is going to be a new human, right? Now, what do you think is going to happen? What do you think? What do you think the name of the human in the 3rd offset is going to be?
It's gonna work, but it's not gonna. It's only gonna paste 0, 1, and 2.
And you're correct. Wow.
Yeah.
I'm proud of
See,
you.
I'm a genius.
So here we can, again, change the name of it. Let's change it to perfect. Also, notice that human has a string, right? And there's two, in C#, there's 2 types of data. There's reference data, and there is value data. In this case, the string is a value data. All value data has a default of 0 per se, right? It has a default. All reference data have a default of null. So reference data will be a class. A class is a reference. Value data will be a struct. A struct is a value. An int is a value. A bool is a value. Any class is a reference. Game object is a reference. For instance, vector3 is a value. Transform is a reference from Unity 3D. All the components like mono behavior, reference type, it's actually a class. You know, things like that. If we go back into here, let's say that we actually want to, when we initialize the class, we actually want to set the name equals to a default of, right? And if we don't set the name of if we initialize it to a new something to a new space in memory, but we don't set the name of it to anything else, then it's just gonna have the default of it, which is little dickman. All right, you get the idea. Perfect. Yeah. That is how arrays work. Do you need any more explanation of arrays, my friend? You want to know anything more in the array?
No,
Okay. There are also different ways to initialize the array, right? This is one of them. Also, notice, I just want to teach you one more thing. If I put this code here, what do you think is going to happen now? What do you think this is doing?
it's
Huh?
it's gonna make an error
Why so?
because we already have an. Oh no! It's not gonna give an error.
Oh yeah, why so? What if I do this?
It's
It's gonna
gonna
be an error.
no. It's gonna make a new. It's gonna make the limit to 10 instead of 5 because you're making a new array.
Okay, what if I do this, right? Is it gonna give me an error?
No.
All right, let's play it.
Oh no! Yeah. It's gonna give you
All right.
because
What does it say? Reference of the object is not an instance.
it's because you have more than two arrays that you want to set.
So you're telling me that this won't give me an error then?
No, it won't.
It won't or it will? Like, make up your
won't.
mind.
For me, I said it won't.
It will.
It does give you an error.
Yeah.
Reason being is because you're saying that this reference is referencing somewhere else in memory. Remember, the new keyword allocates new memory. It doesn't keep the old one. It allocates new memory.
Okay.
So this data right here has nothing to do with the data on the past.
Okay.
Okay, I just wanted to teach you that. Other ways to initialize arrays, instead of saying like that, you can actually separate it. You can say new human, right? Let me get rid of this and I put it. I swear this is possible, dude. I'm not crazy. Okay, I think I have to say new. Okay, there you go. And if you don't put a number in here, you can actually specify the amount that you want. So in this case, it will be an array of size 1, comma. This will have two sizes. See how I'm separated by a comma, right? This will be a size of 3. If you don't put the comma in the middle, it's gonna give you an error. Okay. I know. Something else that you can do is. I got you. It's the same thing. So you will do int a equals to 23, right? All you have to do is just here put a here. It will be the size of a, which is 23. Perfect.
Oh, you're teaching people.
Yeah.
I respect that.
He's like a god.
Epic.
Like Jesus.
All right. I don't know what else to teach you next. I'm gonna go into polymorphism and interfaces and sort of things like that. Any idea what that could be?
No.
All right. You guys always, when you start a new Unity project, you always see that the 2 dots and then mono behavior,
Yeah.
and you're asking, well, what the fuck does this mean, right?
No
Yeah.
one knows.
Right. I have no idea.
All right.
No one knows.
Mono behavior is a class, right? So I can just go here and say public class mono behavior. Let me put it under God. Can I finish? Like, bro, I asked if anybody here knew, and everybody said nobody. Everybody said nobody. It's inheritance, yes. So what this is basically saying is that the human class is a mono behavior. So if mono behavior had a public int a, then human also has a public int a. It's already like, specified up here, so you don't have to specify it again. So in here, let's call this my cool int. And here we create a method. If we create a method, we can actually reference, just like we reference name in between these two lines right here, in between the body, we can say name equals to, we can actually reference the variables from mono behavior, like my cool int. But if we remove mono behavior, you can see that we get an error. It's like, where the fuck is my cool int coming from? I don't know. So this basically, those two dots basically mean that the human class is a mono behavior, and it will inherit everything that the mono behavior has.
So it's made from Unity. Unity made something named as mono behavior.
Exactly. And then mono behaviors, since you derive something from mono behavior, you can actually attach it to your game object, because a mono behavior also derives from, look, let me show you right now. Actually, if I go into one of my scripts, this script, whatever. If I go into this script, oh my God. If I go into the script and I go to where mono behavior is created, you can see that I get a list of the methods and all the members and the things that mono behavior has. And you can see that mono behavior actually inherits from behavior. And if we go to behavior, behavior inherits from component. And if we go to component, it inherits from object. And object inherits from nobody. And look at, so basically mono behavior also has all of this methods and members inside of it. So everything you see here, mono behavior has it. You see the instantiate class? I don't know if some of you can use it, have used it before. Well, don't look at that one, because that one is more complicated. But instantiate, all it does is you can actually call it without accessing any classes or anything else. You don't have to say this class dot this method. You can just say instantiate directly, because it's already inside of the mono behavior, which is derived from object. I don't know if you ever used destroy before, or I don't know if you used I don't know if you used, let me go to my building class again. There's another method. You see how component has that transform that sometimes you use? Okay.
Oh, dude. Man.
Muted. All right. Can everybody?
Yeah. Just mute him. Right.
Okay. Glad you guys can hear me. You see how component has a transform that is just, conveniently spelled out, just so that you can write in anything, like you can just say transform out of the blue and it just comes from butt fuck nowhere. That's where transform comes from. It also has a game object. So you can say game object that, no, that doesn't work. Just the game object is the game object that is attached to. It also has a get component. I'm sure you're familiar with that.
Yeah, sure.
Notice that you can just say get component again out of the blue. You don't have to reference a class or anything. You can just get it out of nowhere because mono behavior derives from component, and component has a method like that. So we go back to
Yeah, but sometimes I find some people on YouTube they remove mono behavior and add something else. Like
well, what do you mean? Like
I don't know. It's just I have no idea.
you can derive a class from any other class. It doesn't have to be mono behavior itself. And then you can use it like a normal class, like you will do with the other things. It's just that if you derive from mono behavior, Unity is able to incorporate more functionality to it because it was built by Unity themselves. I hope that makes any sense.
Yeah, it makes sense.
Okay, I never used this in my life. I don't even know what this does.
No
Yeah,
one.
me too.
Yeah.
I have something that in mono behavior that I don't understand. It's not
Okay.
mono behavior. It's something like a code inside of it, which is enumerator or enum.
IE enumerator, right?
Yeah,
That's an interface. I'm gonna explain to you that in a moment.
and
So and what?
start coroutine.
Okay, I never heard of that one. It's probably an interface too, but let me explain to you this, right? So remember, if you inherit from a class, then it's gonna inherit all of its members. Let me just change this back to mammal, right? Because all humans are mammals. That's why it inherits from mammal, whatever, right? Now, what if you have another class called the byte class, right? And the byte class has a method, a public void byte. I misspelled byte on the top because I'm an idiot. Hold up. Byte, right? Well, couldn't you say, well, I want the functionality of byte in this class. Couldn't I just inherit that one as well? Well, if you do this, you're going to notice that it's going to give you an error because you can only derive from one class. You cannot derive from multiple classes. But you can also add extra functionality from interfaces, from other classes as well. If you make them an interface instead of a class, this will allow you to add it. It won't give you an error, but then you have to come up here and whatever. Then you have to come up here, and although interfaces cannot define a body for their members, so it always has to be like this, and they also cannot specify an access modifier because all interfaces members are public. You cannot also define a field. A field is just an int a. You cannot do this. This is illegal. Okay? You have to make it either a property or a method. A property is just, I don't know if you've ever seen this, a get set.
No, never.
Okay, I'll explain to you later. So then again, if you integrate byte into human, you're gonna see that it's gonna give you an error, right? And if you read it says human does not implement interface member. Interface member byte.byte, which is this byte.byte. So you actually have to make the method yourself and then define it. You know, you have to implement it and then define it. So it's not just writing the name here. You have to implement. So if we go here, actually Visual Studio has a handy little tool. It's this light bulb. You click on it and it says implement interface. You click on it and boom, it's automatically right here. It even puts some code that you don't want. Nobody wants that code. Now every time bytes gets called, it actually does something. So we can do debug console dot write line. You've been Biden's. RAR. Right? And we can say And adding interfaces to classes is just a way to define common functionality between different classes. So now in here you can say, okay, let's create a new variable type mammal, call it a equals to new mammal. Let's create instead of mammal, let's create a human, call it new human. You guys know what bools are, right? You know it returns true or false, right?
Yeah.
All right, well, C# has a handy little operator that you can check if a class is another class. So if, let's say, A is B, I think that's how you do it. CW. Why is this giving me? Huh? No. Okay. Double equals is to check if the references are the same. Well, I guess in this case it makes sense. But what if you want to check if A is a mammal or a human or this or that, and then you want to add a different code depending on what it is, right? So you can say if A is, let's say, mammal, so if A is mammal, you're gonna write A is mammal. And then let's do a little bit more of if statements here. If A is human, A is human. If A is byte, which we integrated byte into human, right? I'm gonna say that A is byte. And now let's do the same for B. B. And in the middle, I'm just gonna put a console write line. What? Oh, okay. All right, I could just do this. And let's look in the console. Let's see what it says. So okay. So here you can see that it only wrote to console that A is a mammal, because A is not a human, does not derive from human. Mammal does not derive from human, and A does not integrate the interface byte. You see, it doesn't have it. Now let's look at human. Is human a mammal? B, okay, human is mammal. You can see that human derives from mammal, therefore it is. Is human human? Oh, obviously yes. And now is human byte? Oh, yes, it is a byte. And it has a byte, right? So now you can say, so let's say you have like many different mono behaviors, right? And you're trying to find if this is that and that is this. Then you can just run a loop, right? So a for loop, and then you will do the for all mono behaviors, whatever, that length. And then you would say if.
What does that length mean?
Okay. All arrays, this is basically a string is an array of characters. So a string is the same as a char array, basically. This and that are the same thing. It's just that they have different names to make it easier to read or to differentiate, whatever. Right? So you can loop through all the mono behaviors of a component and see if they have a common function and see if they have a byte interface, and then execute their code, whatever. Here you can see that I actually use that in my code. If we go to my building, you can see that it has an unplaced, right? And then I have another script that is a fixed update, and every update it will loop through all my well, let me see here. Okay. You can see that every fixed update, it will loop through all the tickables, which is another interface that I have, which are attached to certain game objects to differentiate them. And you see it's gonna loop through all of them. It's gonna say, okay, that, then you're gonna execute their tick method, which is defined in the interfaces. You see, tickable has a tick method. You're gonna execute that, and then go to the next one. Execute that, go to the next one. Execute that, go to the next one, so on and so on and so on. Don't worry about the rest of the code. That is one way that you can use interfaces in your code. Okay, all right. Let me explain to you what properties are. So we know how to create a field. A field is just int a. Well, let's not create it here. Let me make a new separate class. Public class, the high class, as a public string hello string equals to sub g, right? And this is all good and dandy, right? And this is a field. So here you create the reference to the field, you define the type, which is string, and you set it equals to a place in memory, which is this. Now, a property will be the same thing, public access modifier, the type, string, the reference, the p hello, let's call it, for property. And instead of saying equals to something, you're gonna say that this property, you can read from the property, and you can write to the property, right? Or maybe you wanna make it a read-only property. You can say get, and let's make a method down. Let's say that you can make the get, like you can add a body to the get. So you can say this, and you can return super G. Right? Whatever. And now you'll never be able to change this variable, but you'll always be able to read from it. But what if we have a method, right? That we have private integers that nobody can access. We have private things like int num equals to 0. And we have let's make it a string array, call the names, right? And let's create new names like Robert, comma, Jeffrey. Oh, whoops. My name is Jeff. Oh, wait, it's not working because I have to say equals to. Jeff, Carl, Virgin Boy. Let me look at your name on Discord real quick.
Don't.
We have Steezy.
Okay, let me tell you. It's pronounced Stitchy.
Okay,
And
Stitchy.
yeah, it's because it's C and Z. It's a combination of letters, and in Polish it's pronounced ch.
Okay. You guys know this guy? Can someone tell me what this says?
Sorry, we are a bunch of normies.
I can see it. I can say it.
Go.
Dude, like,
You know how to read it?
I'm not gonna say it. But I can say it actually because I don't know. I say it every day, but I don't know today. Why I'm hesitating?
Hey, it's not.
Got him!
It's a
Okay,
trap.
whatever. You can see that we have an array of names, right? And let's make a method that returns a name. So public. No, let's make it private. Name string called ret name or get name. Should I say get? You can name it whatever you want. Doesn't have to be get name. And let's say that we want to return. We want to say num plus plus, and if num is greater than names that get length, then it will be equals to 0. That way, num is never greater than the length of the name, because if it is, it's going to return a null reference exception. Because if we try to reference the offset 10 when there's only 5 things in the array, it's not going to work. Do you understand? Num equals to 0.
Wait, he's back. Oh no, that's not the guy.
And we want to say return names at num. We're going to go in here and want to say instead right? Oh, whoops, forgot to. And so all this is saying is that every time you call this method, it's going to give you the next name. So it's going to be Robert, then Jeff, then Carl, then Virginity Boy. You get it. So now every time that we reference p hello, property hello, right? Instead of saying return super G, you can return the method. And now let's try it out. Let's do a console write line, and let's make a hi first. Hi greet equals to new hi. You get the idea, right? I'm gonna say greet dot p hello, and we're gonna do this 5 times. What do you think? What do you think is gonna happen? What do you think is gonna output to the console? Let me just show you this. Okay. Anybody else got any other predictions?
Show me the code again. Show me.
It's here. Okay. I didn't explain to you what.
On top.
Are you trying to copy it and then
No,
predict?
no. Yeah, I'm trying to see what's happening.
Okay, so it's gonna report it 1, 2, 3, 4, 5 times, right?
It's gonna say 5 random names.
What?
Okay.
There is no random in coding.
This is a list of strings, and there's our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things in the array.
I think it's gonna. I think it's gonna show the first 5 names. I don't know.
No, every second it's gonna spit a random name in the name section. Then
What do you mean random? There is no random in math.
yes, there is. I don't know. Just try.
Okay, not in basic math, maybe.
Yes.
Okay, look.
You can.
Okay, look. Everybody know what plus means, right?
Yeah.
Yeah.
Okay. So remember, every time we want to get or read from this variable, which is right here, we're gonna call this function, and this function does this.
So I have a question. Can you show it first and then explain it? It will be more fun this way.
All right, let's see the names that we got.
See, I I told you it's gonna spit 5 random names.
It's not random.
No, it's not random.
They are random.
No.
Well, let's try again. Let's try again.
I-
If they're random, it's gonna get different names. Let me take a screenshot so we can save it.
We
Right.
don't need screenshot. We can just memorize.
Okay. Let's
Oh,
see what
yeah.
we got.
Okay.
You remember your names?
Those are the first 5 names except Robert.
Oh yeah. Because we start at the number 0 and then we add 1, and 1
Yeah,
is this
yeah.
for Jeff.
Oh, right, because there is plus
okay.
the start. If you right, yeah.
Okay. I guess, does everybody understand what's going on?
Yes,
I do.
it's
Okay.
adding
So
one.
if you would put num plus at the end, the Robert name would show up, right?
All right, let's try.
Oh, okay, now I have no idea what's going on.
All right. Every time we return something, the code after it does not get executed. So when we return, there's nothing below it. That's it. It's the end.
Okay. So
And Robert doesn't get called.
yeah, in the middle. So then,
No.
Why not?
All right, listen.
Okay.
The reason why Robert doesn't get called is because we're saying number is equals to 0, and and it doesn't change until we get to this equation. So it's gonna do the comparison, and the number's still the same. Now 0 is gonna become 1, and then 1 we're gonna get the offset of 1, and that's where it's gonna start. And when this gets called again, it's gonna do the same. 1 plus 1, 2, offset 2. 1 plus 1, 2 plus 1, 3, offset 3. 3 plus 1, 4, offset 4. And you do that 5 times. And since we start at 0, the first number is going to be 1, right? If we start at -1, then you're going to see how Robert does get called. Okay. What if we start at -2? What do you think that's going to happen now? Anybody got any other?
It's gonna stay the same as 0 because, yeah, they're gonna stay the same.
Remember, if you're trying to access a number that is not inside of the array, it's going to give you an error.
So an error, I guess.
Oh, fuck. I gave you the answer.
Yeah, kind of.
Because your index is -1 and arrays cannot be -1 size. Now, what if I make it a 0 and instead of adding it over here, I increment it over here? What's gonna happen now? You think Robert is gonna get print or he doesn't?
Wait a second.
What?
Yeah. I think,
So you
I
think
don't know.
Robert?
I don't know. I have no idea.
All right, let's see what happens. You ready? Okay, let's see what happens. And there it is, Robert. Now, what the fuck is going on, right? Something else that you can do, instead of putting it on the right, you put it on the left. You think Robert will get called now?
You can put it on the left.
Yeah, both sides.
Okay, first time seeing this.
What do you think is gonna happen now?
No idea.
It's still
Right,
the
let's
same,
see.
like 1 plus equals.
But where's Robert? Robert is Goner. All right. What happens is when you put num inside like this, right, out of nowhere, and it's not in its own line, whatever, then it's gonna say, okay, increment first and then pass the value in. That's basically what it's doing, right?
Okay. Right.
But if you say num plus plus, it's gonna say pass the value in first and then increment.
Okay.
That's why pass the value in 0 and then +1. Now my num is gonna change to +1, and the next time it's gonna do pass 1 in and then add 1. Okay. Now I have 2 here. Pass 2 there, and then change it to 3, and so on and so forth. And Robert does appear. And so this is one way we can use properties. At the same time, you can also put this public and do it through that. But I think doing it through a field like this is more elegant, right? It's easier to read. You don't have to say get name and then the parentheses and none of that. It's already automatic. It gives you a new name every time. And let me just do this here like a quadrillion fucking times, right? Look at the code closely and tell me, do you think it's going to fault, it's going to error, or not?
There. No, it's not.
Well, I've. Mm,
So it's going to error? Say no or yes. Don't say
I say it's gonna error.
Okay, we got Virgin Boy for error. Okay. Let's see what happens. And it did error.
it did. Okay. Because the array was too small, right? Like it wasn't.
Yes.
Okay, it wasn't supposed to error. That was an error from my part.
Okay.
Okay, so num, names that length. So let me go back to illustrating real quick. If you create an array, right? Let's say 1, 2, 3. This is length 1, 2, 3, 4, right? So the length is 4. But the offset will always be length minus 1. So the maximum offset will always be 3. And since num is the offset,
Hello there.
and it has to be less than length, whatever L, then when num is equals to L, it's gonna keep going. It's not gonna execute. This is when nums equals L, right? It's not gonna be true or be false. Or you understand what I mean?
Yeah.
Is Carlos teaching some mathematics?
He's teaching
program.
Coding.
So here, if I change this to -1, you can see that it won't fault this time. And we're printing names. Every time it gets to the end, let me see what the last name was. Fagas. It's gonna go back to Robert.
Still funny.
But look at this. I did the same thing like 10 times. If only there was a way to loop all of this, right? And just do it 10 times in a loop. Well, there is. Everybody know how to create a loop, right?
Yeah, right.
Everybody know Virgin, but you know about loops?
He's muted.
For loops,
Yeah.
while loops, for each.
You know for each?
Yeah, for each loop.
All right, some bitch.
No.
All right, let's do something else. To the high method, I'm gonna create a public int called the mega. And I'm gonna call it power. And the power is gonna take 2 integers. It's gonna take a base, an int base, and an int 2. And I'm gonna create a for loop. I'm gonna loop however many times 2 is. And I'm gonna create a new variable. Okay, you cannot name it base because base is a keyword inside of a C#. So if you just put a / there, it's gonna be fine. I'm gonna create a new integer inside of my method called result. And it's gonna start at base, right? And so it's gonna be result will times equals, everybody knows what this does, right?
Can you remind me? Because
okay, I'm gonna do it this way.
Okay.
Okay, you're saying, okay, how can result equals result times something else? That makes no sense, right?
No, it makes sense.
It does. I understand it now.
All right, boy. For virgin boy.
It makes sense.
Okay. So saying this is the same as saying this. So now it's going to loop through, and it's going to multiply result times base, and it's going to write it into result, and it's going to do it this many amount of times. And now since it returns something, I'm going to return result. How convenient. And let's make it a static int, so I don't have to create a reference. I don't have to instantiate it, right? So let's just debug. No, console.writelog, right line.
Every time.
High that power. It takes two integers. Let's do 2 to the power of 32. Let's do 1 to the power of 100. Oh shit, so the power 32 is actually the maximum. Power 30. And now let's see, let's do 5 power of 5. Let's see what the answer is. What the fuck? Negative. What the fuck happened there? Okay, 1 to the power of anything 1. Let's see if that's true.
Oh man, that was so close.
Calculator. Let's do 5 power 5 equals completely fucking wrong. Of course. Why is it wrong? Maybe I wrote my code wrong because I'm an idiot.
Yes, you are.
No, he's not.
It's because you're doing times equals, I guess.
It's supposed to be like that.
No. Because
What?
What was the answer again?
31.
5 to
31.
the 5th. 3125. Okay, I just added 2 1 extra time. So now if I add 1 here, it's going to add 1 less time. Perfect.
Sugoi.
What happened?
What happened?
Okay, I thought you said something.
Nah, I was just.
I don't know.
Yeah.
What else can I teach you? Tony Ching Chong, wow.
This is Chinese.
Fucking wave.
No, you.
Okay.
All right, I don't know what else to teach you. Does anybody have like any questions about anything?
Yes.
Yeah, what's up? What's up? What's your question?
The ceiling.
All right, let's go straight into Unity. Constructors. You can use that anywhere inside of a class. So you know how you instantiate a reference, right? Like hi pee poo pee poo poo equals the new high, right? If you want to call something inside the class, you just go like pee pee poo poo. Hold up. Fuck. Pee pee poo poo dot hello, whatever, right? And that's how you access it from outside of the class. But what if let's say you have a public void the cool method, and your cool method has a fucking string hello. And notice how this doesn't give you an error, even though this hello is the same as this hello. So let's say that you want to set this hello to this hello, right? So we say hello equals to hello. I know, right? So the program is actually thinking that you want to set this hello to this hello. So this itself to itself, basically.
Yeah. So how to?
So in order to differentiate, use the this keyword to defer to the class. So you use this dot hello equals to hello. So this will be this class dot hello.
That's crazy.
Yeah, and you can use this even though you're not doing this. You can use this at any time. Like, you know, it doesn't matter. This is completely allowed. It's not illegal or anything.
Okay, I have a question.
What's your question, man?
It's about enums. You said it before
Oh.
and I didn't understand. You said I'll explain it
Okay,
later.
enums are the most complicated thing in C# ever. There's no way to understand them, first of all. They're so hard to understand, not even the developers knew how to integrate it correctly. All right, to create an enum, enums are basically another container of data, right? And it's just like creating a class. Public enum mega faggot, right? So, you know, they have a public access modifier. They have the type, or you know, the sort of thing that it is, and then they have the type or the reference name, like just like class have, you know, public access modifier, the type, which is class, and the type, which is high. And we go in here, we say, okay, what sort of data does an enum contain? Enum contains numbers as letters, if that makes any sense. So you can have enums that one of them says, usually enums are used for states, right? States. So you can have a state, let's say state of a game. So you can have a playing state, a paused state, a jumping state, a running state. You can have a ugly state. You can have a state of depression. Or you can even have the state of Florida, right? Probably most of you don't get this, but you get my idea. Now,
Yeah.
I don't know if you can see this, but if you hover your mouse over it, it says state that running state equals to 3, which is state that running state, which is enum state dot, which means go into the enum and get the running state, which is equals to 3, right? So this one's equals to 0, then 1, then 2, then 3, then 4, then 5, then 6. Makes sense, right?
Yeah, that's not so hard. So why is it so hard?
Okay, now this is the harder part, right?
Okay.
You can also say state. You can create a new state after putting comma. You can say the no state, and you can set that equals to the largest possible int number that it can ever be. You know, you can put it to, I don't know, 4 million, and that is definitely a state. If you put a state after this, the after state, it's gonna be 4,000,001. I don't know if this is 4 million or 4. Yeah, it is 4 million. 4,000,001. And so it's gonna go in that order. If you decide to put playing to be a state of 10, then it's gonna be, this is gonna be 10, 11, 12, 13.
Okay, I got it.
I don't think you can.
Nice.
What?
But no state is still gonna be 4 million, right? It's not gonna be 4 million plus 10.
Exactly. It's gonna be 4 million, and the next one 4,000,001, unless you specify yourself to be 4 million.
Wait. I have a question. What if you set the no state into like something like 4 or 3?
Or if no state equals to one of these, one
No,
that's already set.
If it's something that's before playing.
Yeah.
I don't think it matters, but it does matter if it's already defined. So running state is 13, right? If we make this 13, it might give you an error.
But what if a no state is 9? Then playing would be 10.
Wait.
Like what if no state is before playing?
Oh, then it's gonna count from there, I think. Look, I didn't know this either. You can set multiple names of state to multiple the same number.
Okay.
I found this out with you right now. If he's
The more you
if
know.
it's what if you set it up here, then it's gonna go 10, 11, 4, 5, 6, 7, 8, 9. But what happens if you set it and this one is, let's say, 6? There's gonna be 7, right? Yeah. There's gonna be 5, 6. Yeah, it repeats again.
Okay. Okay.
And the way you do states is that you create your reference of type state, my state, and then you can say you can have various. You can let's say that the high class has a state for the current state. And you can say PP poo poo that state, the current state equals to my state. Or you can say directly state that and other states that you want are gonna be listed here. State of Florida, running state, things like that. So instead of, sometimes you have a bool for your character controller that says is running. Well, you can make it into a state now.
Okay.
And since states are numbered, you can cast a state into an int. So you can just say like this, and then if you put 4, then it's automatically going to be the state of 4. What if multiple states have the number 4? I don't know.
Okay. Well, there should be an error, right?
Let's make them multiple 4. Hold on. 13. I'll tell you right now. Let's get rid of this. And we see that we get not an error. Let me just put here. Nah, we didn't get an error, because if we got an error, it's going to highlight this. But what if we try to print the state? I'm going to say console right line, PP poo poo.
Current state.
No.
No.
State at 13. Oh, there.
It's gonna choose random. I think.
You think?
Yeah.
Looks like it's pretty other to me.
Why?
Oh man. Deep respect.
I don't know. It always chooses other.
Why the other?
I don't know. Dude, I'm finding this out with you, bro. Like.
Okay. So, like 1 minute ago, I was like, well, that isn't so hard to understand.
That's it. This is all there is to it. It's just words written into numbers. That's all it is.
Then what's so complicated about it?
I was making a joke earlier. This is like the simplest thing to understand.
Ah, okay.
Oh.
But still, you have no idea what's happening right now, right?
Yeah.
So it's not so simple, is it?
Dude, it's just a state is a number. You create like a class, but instead of being a class, it's an enum.
Okay, so why is it always other?
No, it's not always other. It says I came to find out now that it just goes to the second one. Look. So we have an after 2, right? And we have and since we have more than one thing and we cast the number 13 to a state, and we do it multiple times, then you see it's the second one. And if we then change other 3 to the second spot, so 1, 2, you can see that number 3 is going to appear. That's all it's doing.
Okay.
I don't know what else to teach you. Want me to go into Unity and teach you from there?
Okay.
Yeah, why not? Why not?
Okay, in Unity, enumerator. Let's start with that.
Okay, you were saying, my guy? The other guy. You had a question, right? Stitch?
Yeah, I know. I was just saying you can go to Unity because you know.
I thought you wanted to ask something. What happened to that?
I enumerator.
Let this man talk.
Yeah, I didn't have any question.
Okay, if you say so, man.
Seriously.
Okay, first of all, IE enumerator is actually into the system namespace, so we can actually see it right here.
Oh, really?
Yeah.
I actually saw it in the.
It is in Unity too because it's part of the system.
Yeah, I know. I saw it in the mono behavior thing.
Oh, when I clicked on it?
Yeah, I saw it somewhere.
Oh, get enumerate probably. Oh, yeah, in the behavior or component. Get component, get send message. I don't know where you saw it, man.
I don't know. Just go up. I don't think it's component. I think it's object or is it?
Oh, yeah, maybe it is object. You're right. No, it wouldn't be because it's not. Yeah, it's not object.
Okay, I enumerator.
Okay, you guys remember when I was talking about interfaces, right? IE enumerator is an interface. So I'm gonna say cool class, and it actually comes from the system that collections, I think, collect. And there's another one in system that collections that generic. But we're not gonna worry about that one now because generic are a whole separate thing. So I'm gonna integrate it here. IE, no. There we go. IE. Nope. IE enumerator. And now we go to the little handy thing. We click on implement interface and you see that it has a move next, a reset, and a current. And it's up to you to define this. Now, each class that implements IE enumerator, it's up to them how they handle what you see. So an IE enumerator, you can basically think of them as this class probably has an array somewhere. And if you want to get that array, then you're going to have to go, you can use IE enumerator. So if you have an int array, don't get confused. This is just my name. I'm going to name it whatever I want. Like, right? On the move next function, you can say, and you can have another int for current, whatever. Move next function, you can say if underscore current is less than or equals to cool that length, don't forget -1, then return false. And I don't have to put an else statement because remember, if it returns false, then it gets out of the method. So I can say if that return false. If this is not true, then you're going to underscore count plus plus. No, wait. You first have to increment it. And then you want to return. You want to say, you first increment it. You check if it's greater than the thing. And if it's not, then you want to return true. What reset basically does is we can just say, go back to the beginning. Current to the beginning equals to 0. And then what current will basically do, don't worry about this the thing there. This is just the same as saying get. So we want to get return cool at current. Does this code make any sense to you?
Kinda, but.
And this is just one way to implement the IE enumerator. And that's it. Any questions?
I wasn't actually talking about this enumerator, but I learned from it something from it. It was like IE enumerator, and it's inside of a class.
Inside what?
Inside of a class, like a void or something like that, a method.
What do you mean inside of a collapse?
A class.
Oh,
Like a method or
yes, because that one actually implements another interface, which is not enumerator. It's IE enumerable, I think.
no, it's IE enumerator.
All right. Look, when I implement the interface, you see that I get a get enumerator, which is what you want, right?
Wait. There isn't an IE enumerator that I was talking about. I was talking about there isn't one in C#. It's in Unity.
Yeah.
Yeah, that's what I. Yeah.
And here you can just say return this because this is an IE enumerator, or you can return cool because all arrays. If you go to the base class for all arrays, let me just type it here, and when I click on it, you can see that it integrates a bunch of interfaces, and one of them is enumerable, and an enumerable has a get enumerator, which you can just do here. And it also has a structable and iList and many other interfaces. So instead of saying return this, you can just say return cool dot get enumerator. Any more questions?
Can you explain this get enumerator again?
Okay, enumerator
Without the without the one on top. Just remove
without the
these.
enumerable.
Remove these two. Remove.
Is this what you want?
No. The one on top, next to the cool class.
Well, then.
Like that?
Yeah, and just make an IE enumerator. Just type IE enumerator.
Like make a variable?
Yeah, no, you just open a new line. I just type
Like that?
yeah, this one.
You can reference them because if the class derives from IE enumerator, then you can actually just put this class inside of this variable. That's what it does. You will have a reference to an IE enumerator. No, if this class does not integrate IE enumerator, then you're gonna say A equals to this class. It doesn't work like that because this class is not this. Okay, cool, amazing. Want me to take you through Unity or what?
Yeah.
Okay, yes, Unity.
Okay, so here's my project. I'm gonna show you. This is not the most professional type of projects, but this is how I did it. So each one of my buildings. So this is a project where you can place buildings, right? I don't know if it's gonna place them indefinitely right now. No, you can place a building, and you place the building, and it automatically connects to the other building next to it. It's a position kind of thing, right? Whatever. Okay. Let me go into my building class, if I find it. Let me delete these other crap. I mean, if you want to learn something specific from Unity, just tell me. I'll help you. All right. So my building class is a mono behavior, meaning that I can add it. I can add it to a normal game object, right? And it also integrates the interface on placed. So let's look at the interface on placed. Unplaced just has a unplaced method. So here we can see a bunch of crap, and here we can see the unplaced. And all this function is gonna do is that when this method gets called, it's gonna get all the building properties, which are also mono behaviors that I have, right? Amazing. Actually, I wanna now that I'm here, I'm gonna say get private set. Oh yeah, I should have taught you this actually. This basically means that it's a public, you can get it publicly, but you can only set it privately, which means read it from anywhere, write to it from only within the class. So basically you can say A equals to BP, but you're gonna say BP equals to A. That's all that's saying. Right? So now when does my unplaced method actually gets called? Right? Because if I just write it here, it's never gonna get called. It's just gonna be sitting there doing nothing. I don't have a start method here. I just have a onDestroy method. Oh, I should have taught you events, man. Ah, fuck it, some other day. Okay, so when does that unplaced method actually gets called? Let's go to, if we go to my building property, you're gonna see that if we go to one of the buildings already created, you're gonna see that it has a bunch of mono behaviors, right? One of them says building, P out, P in, P stands for property, by the way. It's just another mono behavior I just decided to make to like the idea of a property. That's what it is. CPU clock, you see has a building initializer, an H, which stands for handler, unplaced. That sounds familiar. Let's look at that. You can see that this handler has a self-destroy, and it should actually derive from its handle. What the fuck? Oh no, it doesn't have to because they all derive from building handler. Wow, whatever. So you can see that it has this do method, and its do method is gonna say, okay, it's gonna create. Oh, by the way, var is basically the same thing as saying. So if you say int a equals 3, doing var a equals 3 is the same thing. It's just that the program is gonna automatically assume the right side to the left. Does that make any sense? So if the right side is an integer, then the left is gonna be type integer. If the right side is a float, the left is a float. If the right side is a building, the left is a building. Does that make any sense?
Yeah, I think it does.
Okay, so temporary is actually a array of all the components that have unplaced. See how useful that is? Epic. And we're gonna say that we don't actually need to say this. I had this before because I just got all the mono behaviors, right? And I didn't know which mono behavior was unplaced. So I just had it there because I didn't know I could do it before, whatever. So here I'm looping through everything in the temporary, and I'm calling them unplaced method. So this is where it comes from. Now, who calls the do method, right? Who calls this method? Let's look at another thing that I have here that actually has a little like arrow thingy. Building initializer. Edit script. You see that it has a start, that it has a get component. It will get all the building initializers that are not equals to this, and it will destroy it. What? What? Okay, this should come first. So you're gonna see it's gonna execute all the handlers and what they do, and one of the handlers, like I show you back here is the unplaced handler, which calls all the unplaced methods. And if we look at another script over here, another mono behavior, one of them is a p out. And the p out has a unplaced as well. So this unplaced is going to be called, which just calls this method, which does this, whatever it is. So the unplaced handler, it's going to call all the unplaced mono behaviors.
Hello there.
And what's up? And the building initializer is going to call all the initializers, right? All the handlers, and the handlers call the specific handler of their type. Okay, I hope that makes any sense.
What are you talking about?
I'm teaching C# stuff.
Oh,
yeah,
amazing. What are you teaching?
So I was teaching them how I integrated interfaces into my my project.
I got you. Okay.
Now that we're here, I'm gonna give you the how to use events and delegates. How about that? How about it?
Guys, I'll be right back. I'll go for like 5 minutes.
Okay, I'm gonna wait for him.
Yeah, okay, that's cool.
And while I wait for him, I'm gonna watch my favorite YouTube. All right. I'm gonna teach you about delegates and events. All right. This is a subject that took me very much to understand because nobody explained it to me. But it's pretty fucking easy. What are delegates? Delegates are functions. Delegates are functions that you pass as reference, right? So let's say that you have let's create a cool delegate right now. Let's create this bullshit. So cool class is gonna have a public. Let's create it outside of cool class. Public delegate. Now we need to specify what the delegate returns. It's gonna return a goddamn void. And then we need to specify the name of the delegate. So it's gonna be called cool delegate. And then open and close parentheses, semicolon. This is your amazing delegate, right? So now let's create a reference to this delegate. Let's put it in my cool class because it's cool, amazing, cool delegate. I need a name for it. My bad. My cool delegado. Can you not? Thanks. Jeez, hold up.
Quality typist right here.
Forgot about this.
You need to spend more time on type racer.
Maybe. Right. So I have a public void method, right? And what this does is writes to the console, you're stupid. Actually, I'm gonna do no, I'm gonna leave it like this. You're stupid.
This is hurting my feelings. I don't know how I feel about this, man.
My what?
Your code's hurting my feelings. I don't know how I feel about this.
Okay. You are not stupid.
There we go.
Okay. So now let's do this the old-fashioned way. Create an instance of the class and get a reference of it. Oh, let's use the new keyword that we just learned. Wow. My cool gas equals to new cool class. Nope, cool class. And now let's say my cool class dot method. Watch this. You guys ready? You're stupid. Anybody expected that, right? Like that was the expected thing. Yeah, everybody good? Everybody good to this point? Everybody knows what's going on? Okay. But what the fuck is a delegate then? Okay. A delegate is to set a reference to this method, but as a variable. So it can be this method, or it can be this method, or it can even be this method, right? So how do we add something to this variable? Simple. Let's add this method to this variable, right? So we go into that reference. I'm gonna say my cool class. I'm gonna create a separate thing just so that it's more understandable. So cool delegate Delgado equals to new cool delegate. Is that how you do it? I'm not really sure. Nope. Okay, you cannot do it like this. So let's just create the reference for now, and then let's say that Delgado is equals to my cool class dot method without.
Yeah, you just need the signature.
Okay. So yeah, and then in order to call per se this method by using this variable, we just simply say Delgado dot invoke. We call a method within the method. I know, right?
There's a better way to do it. If you create an event of the delegate type, you can.
Well, I'm getting there.
Oh, okay.
I was
sure, man, because usually it's not done like this.
What does invoke do?
Invoke just calls the
methods added to it. If you use the increment operator, you can add multiple methods, and invoke just calls all of them.
So invoke is just instantiate.
You're confusing my students.
Calls every single function added to the delegate.
They don't know what delegates are, bro. They don't know what events are.
I don't know what delegates are.
No, I have not finished.
All right, man.
Man, we are stupid. We don't understand it.
So remember, a delegate, it's just a method as a variable, okay? And then if you want to invoke that method, if you want to call it, all you have to do is say the delegate that invoke. And we play it.
If you've messed with function pointers before, delegates are the same thing, except they can store multiple functions.
Wait, I remember invoke. Invoke is just like instantiate, but with a delay.
No, it's just calling. Just calls
No, you can make a delay for it.
You can, but invoke just calls it.
Yeah.
Okay. All invoke does, instead of doing, let's say that you want to call the my cool class method, right? Usually how you do it is like this. But since the Gato does not have the name of the method that you put into it, in order to call it, you actually have to say Delgado.invoke.
Could you, I don't know if they overload it, but could you just use the function call operator? Actually, I haven't tried that. Just do Delgado and then 2 parentheses.
2 parentheses.
Yeah, just the function call operator. Yeah, just because I think you can do that. Yeah, okay. Yeah, they overrode it.
Oh, you cannot do this with events, can you?
No, I think that isn't that. It might be. I'm not actually sure. They just overloaded it, and I think that's what it makes it does. So it's probably a little easier to read if you do it like that.
All right, it's the same thing.
Yeah.
This calling method like this and putting it like this, if the reference is equals to this, is the same thing. All right, everybody got that?
Mm-hmm.
Again, a delegate is a reference to a method. Everybody good? What if I make another method, right? Method 3000.
2.0.
What if I make
40,000?
And what if I change this method to, instead of be a public void, it's a public int? Let's see what happens. So in here, first I'm going to see that Delgado equals to that, and then I'm going to invoke Delgado. And then I'm going to copy and paste it 3 more times. 3 more times. And it's gonna be the other method, 3000. And it's stupid. But what happened here? Why can I not add stupid to Delgado? Well, let's look at bro, if you know it, like shut up, okay? Like,
Yeah,
okay,
yeah.
we get it, you know it, man.
Yeah.
Like, I'm trying to teach this, please. Okay. Cool. If we go back to the delegate, you can see that the delegate says that I must return void, and that it takes no arguments. You can say here int a. Can you say int alone? Yes. I learned this today. You cannot say that. I lied. You have to specify int a, int b, whatever, right? So here in this delegate, it specifies that the method must have a void return type, or yeah, return value, whatever, and it must take no arguments, right? If we look here, taking arguments will be this. The return type is this, void, string. All these methods, they don't work. Just like here you can see, this method returns void, has no parameters. I don't know what to call it. This method returns void, has no parameters. This method returns int, does not work because it has to be a void method. So let's delete this. And let me actually change void 3000 to say stupid and retard. There you go.
Your program is disrespecting me. I don't know how I feel about this.
Okay, so that's what delegates do. Now, you can think of events as an array of delegates, all right? Everybody remember what arrays are, right?
Yeah.
All right, so let me create
Warp, do you know what arrays are?
What?
That's warp. Warp. I don't know how it's pronounced. Here even.
I know what arrays are, yeah.
Arrays is like int.
I
array
know that,
A.
that was a joke because he was, you know.
Okay, I actually didn't understand what you said. All right, so you can think as events as an array of delegates. So if I say, I'm not gonna say here because yeah, this in the new class that I made. I'm gonna say cool delegate array. Then I call it the cool delegates, and then I have a method, the invoke method, right? And this method says for each item in this collection, you're going to invoke it. So item will be the delegate. I'm going to say that invoke. Whatever. And so doing this, creating the array of delegates and creating the invoke method is the same as creating the event. So if we go up here and we say public and the event type, well, the event type is going to be a cool delegate. And then we need to give the event a name, my cool event, right? Then every time I invoke this event, all the delegates, all the methods that it has, they're gonna be executed, right? So here, let's create another instance of my cool class. So var whoops, fart clap equals to cool class whoop, forgot the new keyword. Always forget something. And then we can access the event of cool clap or cool class, right? The event is cool event. We're gonna say, okay, clap that event, and the way that we add something to the array, we say plus equals. I don't know if there's any other ways. This is the way I do it. Plus equals another method like method, right? So we say clap that method, and we can add multiples. Since this is an array, we can add more than one. Method 3000. You know what? Why not? Method again, and again, and again. And let's add, and notice here that it won't let us add the stupid one. If you add stupid, it won't let you add it. Error, right? Notice here that I'm not saying open parentheses, close parentheses. It doesn't let you do it. It's just the method name, because open parentheses, close parentheses implies that you're calling the method. Now, to invoke the method, invoke basically means call this, then call this, then call this, then call this, then call this. The way we do it is clap that cool event that invoke, I think.
I think it's just like the calling operator.
Wait, it's not working.
I think it's just the calling operator. I don't remember.
No, but this is how I always do it though.
Oh, I've never.
Cool event.
Yeah. Oh, never mind. Okay.
What the fuck happened, bro?
Do you want me to look it up? I actually forget.
No, I have an event here. Hold up. If we go to my thing, we go to a building. We have an event undestroyed. Tell me I'm crazy. Destroyed event, destroyed.
What is that?
Oh, okay.
Cool event. That's weird. I don't know why.
What happens if I just do this?
Huh. That's odd. Go to the implementation of the class down a little bit. I don't know why it's doing that. Cool delegate, cool event. Yeah, weird. Huh.
It says the event cool class.
Is it not public?
It is public.
Wait, what does the error say? I can't read it.
It says the event cool class, that cool event can only appear on the left hand. No, it's thinking.
It thinks you're adding something to it. Yeah.
Yeah, can only appear in the.
Maybe there's a function to invoke an event, like an explicit one that you pass the event. I'm gonna fucking look this up right now.
No, dude, look, I have an event right here.
Yeah, that's what is weird about it. I don't know why it's acting like that. Maybe you can only invoke it in the class it's in. Maybe it's a private function. Maybe you can only do it in the class it's defined in. All right, I'll give you guys some tips. So if you
Hello?
He's back. The Jesus King has himself.
The boy is back. He is back very much.
Did your shit crash?
It's thundering outside.
Oh.
I see. That is.
Do you figure out how? What was the problem?
Oh no.
We completely forgot about it.
I still don't know what the problem is.
For that.
The event.
Move it out of. Maybe it's like a private function. It can only be called where it's declared.
No, dude. No, bro.
I haven't checked it. I really don't know. I don't have the whole project.
Oh, it is. Oh yeah, maybe it can only be called within its class.
Yeah, I think it's protected. What is it called?
Oh, because the event is inside the class. If I put it outside.
There you go.
Today we are going to be mining for diamonds and hopefully we
What is that noise?
okay, let's go outside now or maybe
What is that noise?
Just some, I don't know. He's watching something probably on his phone.
today we are going
Hello guys, this is my welcome to my Minecraft Let's Play.
Very good.
Right, I'm gonna go back to writing my own code. And I go back to making my own game again.
Yeah, your
Your
own.
own game engine.
No, game. Unity.
Oh, I thought you said game engine.
That would be cool though.
Huh?
Hey, you guys, I need some help. I always get a call from this guy. Can someone translate?